Number 1 asked you to decide whether or not each relation below represents a function, and then to circle the functions. So remember, every function is a relationship between an input and an output. So input is usually the x, output is usually the y. So input of -3 gives you an output of 1. Input of -2 gives you an output of 3, and so on. Each one of these inputs goes to exactly one output. So if I asked you an input of -1, you'd say output -2. Input of 0, output 5. So if that is the case where each input goes with exactly one output, then it is a function. So A is a function. We'll circle that one. B, you'll notice that we have a situation here where an input of 4 sometimes gives us an output of -5, but an input of 4 also gives us an output of -7. So that's a problem on whether or not this is a function. So this would not be a function because the input of 4 has more than one output. So not a function. C, now with a graph, we have the vertical line test to help us determine if it's a function or not. So if we draw some vertical lines down here, we see that each one of those vertical lines only crosses the graph once, which means for an input along the x-axis, it goes to exactly one output. Input here goes to one output. Input on the x-axis goes to one output. So that is a function. Passes the vertical line test. D, look at all the inputs here. So x, y, remember every x value is an input, every y value is an output. Does every x value go with exactly one y value output? No, it does not, because if we see the input of 4 goes to -11, but an input of 4 also goes to -13. So that would not be a function. E, input of 3 goes with the output of 2, input of 7, output of 1, 5 goes to 0, 1 goes to -2. Each input does have exactly one output, so that is a function. F, vertical line test, we can see in a number of places here, the input would go to more than one output. Does not pass the vertical line test, so that would not be a function. Number 2, look back at the table from 1a, list the domain values and the range values. Remember, domain simply means all of the possible x values. We use the little bracket here to represent our set notation. So all the possible x values back in number 1a would be back up here, -3, -2, -1, 0, and 1. You wouldn't have to put them all in order, but generally that's helpful. So those are all the possible input values, all the possible x values. The range is all of the possible y values or outputs. So if we look at all of the y values back here in number 1a, you've got 1, 3, -2, 5, -4. So the range would just be to list those. Again, you don't have to list them in order, so I'm just going to list them the way they are here. If there were any repeats, you would not repeat them when listing the domain or range, because you're just listing the possible x values and the possible y values. Okay. Number 3. Now this is our function notation, so if we can just remember that the number inside the parentheses here is the input and which function it goes with. So this is g of 3, which means 3 is going to go into the g function for the input. So it's going to go in place of the x in the g function. So g of 3, we put 3 in for x over here. That would be 3 squared minus 2. Now just use order of operations. 3 squared is 9, and 9 minus 2 is 7. So our final function notation would be g of 3, so input of 3 gives us an output of 7. F of -5. So if we're looking at the f function, that means that we're changing over to the one with the letter f. And again, -5 in the parentheses means that's the input. So we're going to put -5 into the x spot for the f function over here. So f of -5 is equal to 6 plus 3 times -5. So -5 is going to go into that x spot. Now just use order of operations. Got to do 3 times -5 before we add. Remember PEMDAS here. 3 times -5 would be -15. So 6 plus negative 15, or 6 minus 15 would be the same thing, which would be negative 9. So input of negative 5 gives us an output of negative 9. All right, C is now different. Notice in part C that you are not being given an input, you are being given an output. Notice that the 12 is on the other side of the equal sign. It's still the f function here, though, so we're still going to go back to the f function, this function here. But in this case, we're going to put that 12 in place of the whole f of x spot. So we don't know what x is. We have to work backwards. So we're going to put 12 at the beginning of that equation, and we're going to work backwards to figure out what x is. So this is different now because now we're using our solving steps, our SADMAP steps. Working backwards, we'll subtract 6 from both sides. So that gives us 12 minus 6 is 6, so 6 is equal to 3x. And then we will divide by 3 to undo the multiplication, and you get x is equal to 2. So that means the input is 2. We already knew the output is 12, so we can just write now with the input f of 2 equals the output of 12, which we already knew. So f of 2 is equal to 12. All right, D, same sort of idea. Negative 3 is now our output value. Once again, we're looking at the f function here. So negative 3 being the output for our f function. So negative 3 is equal to 6 plus 3x. Now we're going to use the same steps as the last problem here because it's the same function. We'll subtract 6 from both sides. So we get negative 9 is equal to 3x. Divide by 3. So negative 9 divided by 3 is negative 3. So x is equal to negative 3, which happens to be the output also. So input of negative 3 gives us an output of negative 3. We already knew the output. We just worked backwards and figured out the input was also going to be negative 3. All right, E and F now are our composite functions. So remember what we have to do here is we have to start on the inside and do g of 4 first. So that means that we're going to put 4 in to the g function here as the input. So g of 4, it turns out to be 4 squared minus 2, which is 16 minus 2, which is 14. So if we input 4 into the g function, we get an output of 14. Now, in the previous problems, we were done at that point, but now, since it's a composite function, now we have to look at the f part. So we now know that g of 4 is equal to 14, but now we have to put that in to the f function, because it's composite means it's one function inside of another function, so now we have to do one more step here. So we have to put 14 into the f function. So the f function is up here, remember, 6 plus 3 times x. So 6 plus 3 times, we're going to replace the x with 14. So now we work that out to be 6 plus 42, which is 48. So our final output is 48 here. So now we can write our final answer is f of g of 4 is equal to 48. So in other words, I'm just copying down our original statement here, f of g of 4, and we figured out the final output was 48. Should be 48. All right, last one here, same idea as in part E. It's a composite function. Start off what's on the inside, f of 2. So that means we're using the f function and putting 2 into the f function. So f of 2 into the f function be 6 plus 3 times 2, which would be 6 plus 6, which is 12. All right, so the output for f of 2 would be 12. But then, just like the last one, since it's a composite function, now we have to look at g of that whole thing here. So now g of 12. So a g of 12 means we're going to put in 12 for our x value in the g function. So remember the g function up here is g of x is x squared minus 2, so we're putting 12 in for x there now, which would be 144 minus 2, which is 142. So our final statement, we're just copying what we had originally here, g of f of 2 is equal to our final output of 142.